slope-intercept form, a step beyond direct variation, so just so we can get these in context with each other, because that's important. What we just talked about was this, y equals mx, that's direct variation. We call that direct variation. And we're going to take that up a notch. So slope-intercept form, when we talk about what that is exactly, we're going to say y equals mx plus b. So we've added this part here. That's going to be our intercept. And we talk about intercepts. Intercepts are where lines cross specific places. So in this instance, what we're talking about in slope-intercept form is initially we have m, which we know is slope. So the slope of that line, the steepness of it as it increases or decreases, is represented with m. Then we have b here, and b is our intercept, and in this case it's our y-intercept. And what we should know about the y-intercept is the y-intercept is where the line crosses the x, no, not the x, of course it's not the x, because it's the y-intercept, where it crosses the y-axis. So when we get an equation that's in this form, y equals mx plus b. Now when you see it too, the y will still be y, the x will still be x, but the m and the b will have values like these examples. We'll be able to tell what the slope is and the y-intercept. So let's just look at these two examples right here. In this first linear equation, which graphs as a line, we know that the slope is 1/4, because that's where it is. It matches up exactly like this. And we know that the y-intercept is -2. So it's going to go through the y-axis at -2. And what I would tell you is that x is 0 at the y-axis. So it's going to go through at 0, -2. In the second equation here, kind of a little mystery. There's no coefficient that we see literally, but we do know that every variable that we have that doesn't have a coefficient does secretly have that coefficient of 1. But in this case, it has a coefficient of -1. So we'd have a slope here of -1, and I'm going to write it as a ratio or fraction. Write it as a ratio because then I have an idea of how it rises and runs, how it moves vertically and how it moves horizontally. And then my y-intercept, which I neglected to do in green, is going through at +2, which means I'm at 0, 2. So that line will cross through the y-axis at 0, 2. Now if we go back and just look at this as a reminder for slope, what we know is that this slope means that that line is going to go up 1 and right 4. What this line is going to do is go down 1 and right 1 as it travels. If we're given the slope and the y-intercept, we should be able to write an equation in slope-intercept form. So don't forget our slope-intercept form is y equals mx plus b. Critical in this is just remember that the y and the x are going to stay. And then we're just substituting in values here. So this says my slope is 6/5. Just a reminder, that means that that line would go up 6 and to the right 5. And as I write this, I'm going to say y equals my slope, 6/5, times x. And then my y-intercept is 8, which means I have plus 8. That's not too tough, but let me show it to you a different way and then see what you think. If I change this 8 here, we're going to try the blue. Let's see what happens here. To -8, that's pretty good. If I change it to -8, how is that going to change my equation over here? Well, I'm still going to have the same thing for my slope. y equals 6/5 x, and now I have -8 for my slope. Well, in my format it says plus b. Well, that's sort of a misnomer. What it just means is we want the term b here. So here our b is -8, so I'm just going to put -8. Let me highlight that with my purple. -8. What you probably don't want to do is this. You're not going to want to write this like this. Y equals 6/5 x plus minus 8. That gets kind of junked up. As soon as you start adding too many signs here, it gets a little bit confusing. If we're adding a -8 to something or just combining it, then it's the same as just subtracting 8. So going with that -8 is perfectly fine. Now we have a graph. And from this graph, we can get a slope-intercept form equation. Let's not forget what we have here for slope-intercept form. Y equals mx plus b. The things that we need are a slope and a y-intercept. So first thing I'm going to do is let me find the slope first. And going back to slope formula, I've got m equals y sub 2 minus y sub 1, or x sub 2 minus x sub 1, and x sub 2 minus x sub 1. I'm going to pick this as my point 1. This is my point 2, just so that I can keep track of it. Subtract my y's, 4 minus 5 over 3 minus 0. Remember, you've got to go from one point to the other, from one point to the other. So then that's going to be 4 minus 5 is -1, 3 minus 0 is 3. So I've got a slope then of -1/3. And now I need a y-intercept. Now we have a vision of what the y-intercept is. As this line travels, it's crossing the y-axis. I hope you can see that. The y-axis at 5. Now I don't want to just call it 5. I want to be sure that I know what the sign is too. This is positive 5. So what I know then is that b is plus 5, or we can write that as 0.5. Now, go back to our form, y equals mx plus b. We take y equals mx plus b. Then we're going to have y equals, let's put the slope in, -1/3 x plus 5. And there's our slope-intercept form. We can check that slope too by doing just a simple count between those 2 points. And we can see that this goes down 1, -1, and then 1, 2, 3, plus 3. So there's my change in y, my change in x, my change in y, my change in x. Let's graph an equation in slope-intercept form. So I'm going to do it 2 ways. First is I'm going to use a table, then I'm going to use the slope and the intercept. So in this one, I'm going to use a table. So let me just write the word table here. And to create a table from here, I'm just going to use some inputs and some outputs. The x's are my inputs, the y's are my outputs. So if I put 0 in for x, -2 times 0 is 0, plus 1 is 1. If I put 1 in for x, 1 times -2 is -2, -2 plus 1 is -1. If I put -1 in for x, -1 times -2, +2, 2 plus 1 is 3. And then I can just graph these 3. So let's take a look at that. I've got 0, 1, I've got 1, -1, and I've got -1, 1, 2, 3. And from that, I use my straight edge, put that on my graph, line up those corners, and then draw my line onto my graph. Put my arrows, because that goes on forever. So, if you're ever stuck, you can always use an input-output table here to figure out how to graph this. But, here's the advantage of slope-intercept form. So what we know is the slope. We know that the slope equals -2 over 1. We know that the y-intercept is 1, which means that I know that my line goes through the y-axis here. This is my y-axis, that's my axis, goes there. And then my slope is down 2, right 1. So down 2, right 1, down 2, right 1, down 2, right 1. What's interesting about that is that the inverse of that is true too. If I were to say positive 2 and negative 1, which is an equivalent fraction, it's still negative 2. I would go up 2, left 1, up 2, left 1. And then I draw my graph. Exactly the same. So there's an advantage to this, using your slope and your intercept, being able to identify it and then graph it from that. But if you're ever stuck, the table is always there. If anybody asks you to generate 5 points from that, you could do that automatically. Just pick 5 inputs and get the corresponding outputs. A special case. Here we've got slope. We're talking about slope-intercept form. We look at this and we want to determine what's the slope, what's the intercept. If you were to say, like, hey, you know what, I know the slope is 4, and the intercept, the y-intercept there is 12. There's a problem with that. And the problem is that this isn't in slope-intercept form. Slope-intercept form has to be y equals mx plus b. This is not in that form. So in order to get it into that form, what we've got to do is a tiny bit of algebra beforehand. Let's get this term over where it should be on the right side of the equation from y. So let's subtract 4x from both sides. And then we move this out of the way. And once I subtract 4x from 4x, I get 0 plus y. And that 0 we don't usually write, but I wrote it just so you know that that does actually happen. Equals, now I've got negative 4x minus 12. Are those like terms? No, they're not like terms. So because they're unlike terms, we just literally have the piece moving over there. So this just becomes negative 4x, and that's a positive 12, so it stays positive 12. Now that we're in slope-intercept form, we can determine the slope and the intercept. The slope really is negative 4 over 1, down 4, right 1. The y-intercept is still 12. That didn't change. But the direction of that line certainly did. It went from increasing to decreasing. All right, let's look at the vocab. Ding. The vocab. We have to know slope, intercept, form, which is y equals mx plus b. We need to know what a y-intercept is. Where the line crosses the y-axis. And we have to be able to move back and forth from those things. It's things to not forget too. Don't forget slope formula. Don't forget an input-output table. Don't forget that slope is a ratio that is rise to run. So this would be up 2 and right 1. Keep all those things in mind. This is really a unit that chapter that builds on itself. So all those things matter. Okay, good luck.